Assalamu alaikum wa rahmatullahi wa barakatuh. Now, the next video, we're going to talk about the reality of absolute zero in two objects. Is it possible for two objects, the distance between them to be absolutely zero? So it seems to be like, what would that mean for there to be absolute zero? What would that mean? Okay, so let's start from two objects. Let's say the Earth and Mars. Is it possible for them, for us to, how will I say this? For them to absolutely touch? Is it possible for them to touch absolutely, such that there's no distance between the Earth and the Mars? Is it possible? It seems to be that for them to touch in reality, where there's absolutely no distance whatsoever between Earth and Mars, they will become one object. If that should happen, then the Earth and Mars, they will become one object, because there will not be anything that distinguishes them. They are not separated by any distance whatsoever. They will merge into one thing. But the problem is that really possible? It seems to be that it's not possible to get to that distance. Okay. Now, the other problem is that we are presupposing that the Earth itself is one thing. We are presupposing that. So we think that the Earth is one thing and then the Mars is another thing, and then we can do this experiment. But what about the Earth itself? The Earth itself is composed of things that we can ask the same question, that are they absolutely close such that they are one thing? But it seems to be that no. The particles of the Earth itself, they are not close together. They have some distance between them. Okay, they have some distance between them. There's no absolute zero between the distances of the particles of the Earth itself. So now we go to that level, because now we realize that experiment, we are really presupposing a lot. So we go to the Earth itself and say, you know what? Let's deal with the particles of the Earth first. Now, if you go there and you bring two particles of Earth, why are we even calling them one if they don't touch? You see, they don't touch, because for something to touch, in reality, in the essence of the way we use it, is that there's no distance between them whatsoever. But it seems to be that fundamentally in the universe, this thing is not possible. There's nothing that is like this. So you will see, like, if you bring two particles together, okay, let's say two stones, they can never touch. It's not possible for them to touch, because for them to touch, they'll become one. So they cannot touch. Now you're presupposing the stones, each one of them is one thing itself, but it's not. You can break it. You see, like, it can be broken. So it seems that anything that can be broken as such, they are not really one thing. If they can be broken, that means they are composed of many things that don't absolutely touch. Okay, then you can go to even smaller length and look at the molecules, and then you go from the molecules, you realize that those ones too can be broken, and therefore there's some gap between them. And then you go to the atoms. Now when we reach the atom can be broken too, as we found out, into some other things. And those things, that means there's a gap between and by the way, this is all scientific. All I'm telling you is just some kind of funny stuff. It's scientific, okay? It's not possible. Why? Do you know, like, the atom, they tell us, okay, the molecule is composed of the molecule of water, H2O, that has hydrogen, oxygen, okay, two oxygen this thing, and then hydrogen. There's some force that is binding them together, okay? They don't absolutely touch. There has to be some force that is holding them. If not, they'll just fall apart. So that's what's going on at the fundamental level. Now in the hydrogen atom too, there's some force holding the nucleus and the proton, neutron, and electron. There's some force holding those three things together too. That if that force wasn't there, they will fall apart too. So it seems to be that there has to be some gap between everything. The only thing that binds everything, seems to be like, so there's some kind of force binding everything together, making them as close as possible. The closer they are, the more united it seems. But there's no absolute unity. That's the point. There's no absolute unity, so that you can never actually touch anything. But the question is, let's go, when we now reach that level of the proton, neutron, and electron, which are in the atoms, we are also presupposing that they are one thing. So we can continue this process as far back as possible until we get to a fundamental thing that this one is absolutely one united thing that cannot be broken, is not composed of anything. Now, it seems to be that scientifically, like this, if you look at the history of science, anytime you reach that point that, this is the point, we cannot go further than this, there will always be people that will come in the future and come and say, these guys thought that was the end. Guess what? You're wrong. We can divide it now. Okay? It just depends on the tools that you have. Now, some scientists are looking ahead and they're like, you know what? Let's think about something that nobody can go further than that. No matter the tools that they have, it's not possible that they can go, even though that's what everyone says. But these guys are actually trying to find that thing. Now, there's something called the Planck's length. They say this Planck's length, nothing can be lower than that, because anything lower than that is just, it doesn't make any sense. Okay, that's their point. But guess what it is? It is a number. It has a number. It has a figure. That Planck's length, it has a number. And the problem with numbers is that numbers are infinitely divisible, or you can add them infinitely. You can add numbers infinitely, and you can reduce number infinitely, such that any number you get, there can always be a number lower than that or a number higher than that. So that Planck's length, there is always a number lower than that. Whether it makes sense or not, that's not the point. You're missing the point. We are not saying, can we see it, or we're saying, can we go lower? And as long as there's that possibility of going lower, we will go lower. Okay? So now, it seems to be that means that everything is now somehow composed until you want to reach a fundamental unit, that one is indivisible, no matter what. But this is the problem. I'll end with this. When you reach that point, let's say you are thinking about this one, there's no way you can divide it. It has to be, is it going to be like a point? But a point has extension. Like, draw a point, put a point on somewhere. But the point, ideally, is not supposed to have any size. And if something has no extension, no size, what is that? It is immaterial. It doesn't exist. It's nothing. If something doesn't have a point, a size, or an extension, it's not material. Therefore, it's nothing. It's immaterial, at least, to say the least, or it's nothing. Now, how can immaterial things or nothingness come together to compose one thing, to compose material things? How do you move from immateriality to material? How do you move from no size to big sizes? That is the issue. Who is going to solve this problem for us? Many people have attempted this. Some have just bite the bullet. Some people just bite the bullets and just affirm some kind of irreducible material thing. It can be immaterial, so it has to have size, and they don't want to go lower than that. They will just close their ears. Okay? And some people will just go spiritual and be like, nothing exists, bro. All this material stuff doesn't exist anyway. It's all illusion. Like Leibniz, my new favorite teacher, Leibniz. Okay? He just went like, all this stuff is immaterial anyway. But the point is, you see, like, this is not as easy as people think. You will reach a point where you want to stop, because you know it's infinitely possible to go on. And that's one of the benefits of philosophy, not just teaching you science with numbers. With philosophy, we can go to the end of the line and ask questions like, at the end of everything, what do you want? Such that now, there's no difference between us and the Greeks. The Greeks already thought about the end of the line. Now you thought they were dumb. They are not dumb. When they talked about mustard seeds and how mustard seeds, they thought that's the smallest thing. To them, they are saying, they are presupposing that the smallest thing is the mustard seed. But if it's the smallest thing and it has no weight, they were using like weight. They're saying, if something has absolutely zero weight, how can bringing more of them together give you some kind of weight? So they are saying this doesn't make any sense. That's the exact same question that I started off with, saying that if we get to absolute zero, then adding more zeros doesn't make one. So anyway, let me see what you guys are you aware of this kind of thing? Do you understand? Do you have any answers to this? And do you have anything to add? So let me see what you think in the comment section. See you guys later. Wassalamu alaikum wa rahmatullahi wa barakatuh.